Hello, my name is Ardi and we are going to solve problem 3.8 from Sadiku book. So the question is using nodal analysis, find V0 in the circuit of figure 3.57. Okay, this is the figure and V0 is this voltage across this 4 ohm resistor. Okay, the first thing that we need to do is pick our ground, and I think I will pick the bottommost node here as our ground. So the voltage in this node here will be 0. Okay, and then this is V0, right? Because this is V0 from the ground. So I will have V0. And let's name this node here as V1. Okay, and then we have another node here, which is 5V0 from the ground. So this node has the value of 5V0. Okay. And what can we do? I think we need one more value here, which is this node here. Remember the difference between the positive terminal and negative terminal of a voltage source, it has to be this value here, which is 60 volt. So we will have this as V1 minus 60, because if we subtract them, we will get 60, right? And now let's assume the direction of the current. I think I will assume this going down here, and I will assume this going to the right, and this I will assume this will be going down, and this will be going to the right. Okay, what we need to do first is do KCL at this node here, which is V0. Let's do exactly that, KCL at node V0. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, there is no current that goes in here. All the currents, this one and this one, are going out. So we will have 0 on the left hand side. And then that will equal to this current here, which is V0 minus 0 divided by 4. V0 minus 0 divided by 4. And then this current here, that will be V0 minus V1 divided by 6. Right? Because the resistance between them is 6. And I think we can multiply both sides by 12, I think. Yeah, 12 is good. 0 multiplied by 12 is just 0. 4 and 12 will cancel into 3, so I will have 3V0 minus 0. And then plus, we will have 2, because 6 and 12 will cancel into 2, so we will have V0 minus. Okay, and we will have 3 multiplied by V0 is 3V0. Okay, let's maybe do that. So 3V0. And then plus, let's distribute these two. So I will have 2V0 minus 2V1. Okay, 3 plus 2 is equal to 5. So I will have 5V0 minus 2V1 is equal to 0. Okay, maybe let's have this as equation number 1. Okay, we have two variables, so we need one more equation. So equation 1 here is not enough. Let's do another KCL at node V1 to get the second equation. Let's do that. So I'll have KCL at node V1, which says that the sum of the current that goes in will equal to the sum of the current that goes out. The only current that goes in is this one, so I will have V0 minus V1 divided by the resistance between them, which is 6. Okay, and then the other currents that goes out, this current here, but we cannot calculate from this voltage source, but we can calculate from this resistor. Why? Because this is in series, so the current will be the same. So from this one, we can get V1 minus 60 minus 0 divided by the resistance between them, which is 20. So you'll have 20 there. And then and then we will have plus this current here, which is V1 minus 5V0 divided by the resistance between them, which is 20. Okay, I think we can multiply both sides by 60, I think. 60 will be good, right? 60, because all the denominator will be cancelled. So we will have 6 and 60 will cancel into 10. So I have 10 V0 minus V1. And then this will equal to 20 and 60 will cancel into 3. V1 minus 60 minus 0 is just V1 minus 60. And then this one, 20 and 60 will cancel into 3. So we will have 3 multiplied by V1 minus 5V0. Okay, that's good. Let's distribute this. So I will have 10 V0 minus 10 V1. And then we will have 3 V1 minus 180. And then we will have 3 V1 minus 5 V0. Okay, let's move this minus 5 V0 to the left hand side. So we will have 10 plus 5, that will be 15. 15 V0. And then we will have 3 plus 3 is 6. Let's move it to the left hand side. So I will have minus 16, I think, minus 16 V1. And then on the right hand side, I will have minus. I think that's all, right? Let's check. 10 plus 5, yeah. Minus 10, minus 3, that will be minus 16. Yeah, I think that's good. So this is the second equation, which is equation 2. It's good. Now we have 2 equations and 2 variables. We can find out using calculator. Let's set up as equation solver. Equation solver number 5. So I'll have number 5. 2 variables is number 1. Then we will have 5. Then minus 2. And then 0. In the second one, I will have 15 minus 16. And then minus 180. Okay, so we will have V0 is 7.2. Okay, V0 is 7.2 and the unit will be volt. And then V1 from the equation, that will be 18. So I'll have 18 volt here. Okay, and what is the question asked? V0. So we will have V0 here. So this is the final answer for this question. Thank you for watching. See you in the next video. Bye bye.